Thank you, Michael. Our next guest is taking the fight against climate change a step further with a nuclear solution. With immense potential for both good and destruction, could nuclear energy be the solution to climate change? Well, it's my pleasure to welcome Troels as he shares about fighting climate change by rethinking nuclear energy.
Hello, I'm Troels Schönfeldt. I have a PhD in nuclear physics, and I'm also the CEO and co-founder of Seaborg Technologies. And I will tell you about us and the technology we are trying to market. And as you see on the slide here, rethinking nuclear is a very important part of that. But let me jump straight into it. So we're in Europe, and in Europe, we are in the luxurious situation that renewables are very efficient. But we often forget that there are vast regions of the world where that's not necessarily the case. One such example is Southeast Asia, where there are no wind because it's on equator. There is cloudy days because it's in jungles surrounded by water. And there is no high altitude rivers, so no possibility for hydropower, or very poor possibilities for hydropower. Simultaneously, it's a very high population density, so there's a lot of people that needs power. Today, Southeast Asia is expanding the energy grid very rapidly and slowly becoming industrialized, which is very good. The problem is that energy comes from three sources. There are three sources available, which is coal, gas, and nuclear. And with nuclear being the most expensive of those sources, the choice is fairly easy. And today, coal is being scaled at as if there was no tomorrow. And if we are to ask ourselves, with the problems that we have as a planet with CO2, there might not be a tomorrow if we keep scaling coal like that. On the other hand, these regions don't really have a choice. They are running out of energy and they need to get more to industrialize. So it's only fair that they expand. So in our opinion, we need to develop alternatives for these regions that are cheaper and better. And that's what we're working on. So the fundamental hypothesis here is that the politician has been talking about getting rid of pollution and CO2 since I was a little kid. And still, there's nothing that has been shown from the emission curves. So you still cannot see any impact from that. So there's a lot of talk. If we are to solve this problem, our assumption is that we need to develop products where the manufacturer and the owner can earn money while the user of the products can get a better product and save money. So it needs to be cheap. That's absolutely fundamental. And with the energy need of this planet, we need something that can scale at an insane speed. So this is what we do. We basically want to outcompete fossil fuels on market terms, and we'll do that using shipyards. Because if you can develop small enough nuclear reactors, you can deploy energy projects on barges, and they can be built in regions with good and high educated workforce and deployed in regions without it. And shipyards has that magic ability that they can spit out a lot of products in a very short time, and they know how to move vast amounts of steel. So it's very important with the speed of deployment here. So first, what is the magic behind our technology? In a nuclear reactor today, you have these rods where you run the chain reaction and generate heat for energy, for electricity production. But if there's a rupture from these rods into the environment, a lot of gas come out. And that means that the accident consequences very, very high because it's radioactive gases that you cannot breathe, and gases don't care about national borders or continental borders for that matter, or the fence around your facility. So what we take is, we have a salt, and I have some here. It comes in different colors. You can buy it in healing stores because it's really good for your spirituality. It's also really good for nuclear power plants. And in nature, it's a salt, but it's in effect a rock. It doesn't dissolve into water. It doesn't release gases. It behaves as a rock. So what we do is we take this rock, we melt it, we dissolve uranium into it or nuclear fuel into it. We pump it into our core and generate energy. The magic is not in the operation, it's in the accident. If there's a terrorist attack or a meteor or an act of war that explodes this unit and spreads this salt, it solidifies and turns into rock and stays where it got to. So there's no way to disperse this material outside the fence of the facility, which basically changes everything. Suddenly you have a nuclear facility which is contained within the fence, even doing accidents. And that changes how we deploy nuclear, where we can deploy it, what processes we can apply it to. It changes the regulatory demands, and it changes the regulatory processes we can apply. It changes how we can manufacture it, and very importantly, it simplifies the safety a lot, so it makes the products much cheaper. So what we're designing is out here on the right. It's a nuclear core. We pump in salt to the core, circulates around in the core, and becomes hot. We extract that heat, and from there, all of the rest of the elements of the nuclear plant is off shelf. We just generate steam and run a turbine and generate electricity. We have some really powerful bullet points connected to this reactor. It cannot melt down or explode, which is very good. Even better, if you actively bomb the plant or similar, it cannot spread the radioactive materials in gases or in air or water. Also, it cannot be used for nuclear weapons, which is of high importance in these emerging markets in the developing countries, because obviously you cannot have proliferation risk there. So it enables us to go there. And then lastly, which is actually probably the most important point here, is that we can operate this nuclear power plant for 12 years without refueling. If you think about what that means, it doesn't mean a lot if you are in a big city with good logistics. But if you look at these developing countries, a lot of them have regions of poor logistics, where it takes decades to get the basic logistics necessary to build the first energy production. We can shortcut that. We come on a barge built elsewhere. We can be operated remotely. We can plug into the grid even before it's built and expand the grid and logistics from our power plant. That's impossible with coal and gas because you need the logistics to bring in the coal and gas. We operate for 12 years with no refueling. Very important in poor logistics regions. Also, it's worth mentioning that this technology is not entirely new. It's actually been tested 3 times before, twice in US and once in China. One of them ran for 5 years, and there are good reasons why it wasn't commercialized back then. Those reasons are no longer valid, and we have some IP there. I don't want to go into that in this talk. I think it's too short, but at least today we can solve some of the challenges that they couldn't solve back in the 60s. So what we imagine doing here is a little bit copied from the Danish wind industry, which has very successfully deployed wind turbines many places. We'll take these high quality components such as pumps and valves and order them from around the world and preferably around North Europe. Then we'll ship them to our factory, preferably in Denmark, next to our development team. We will assemble the units. Then we'll put them on a truck. And it turns out that our reactor is so compact that it can fit into a 20-foot container. So we can easily take that unit, put it on a truck, ship it to Korea, where they have a very efficient and excellent high quality maritime industry with shipyards and all of that. So they can then build the barge and put a turbine on it. We bring the reactor and install it there. Then you have a turnkey power unit that you can ship to wherever you want in the world, plug it into the grid. It's as easy as it can be to plug it into the grid, but plugging stuff into the grid is obviously not easy, but it's as easy as it can be. We can not only deliver electricity, we could also deliver heat. So a lot of people is talking about power to X. Personally, I think that's a good idea, but an even better idea is heat to X, because you save a lot of energy efficiency. You cut out of the loop because you don't have to convert from heat to power first. So here, I've already mentioned a few times that this barge is important. What do you gain when you build it on a shipyard? Well, first off, shipyards are really good at serial production. Building 100 ships is not new to them. So they can build a massive amount of units in a very short time. So serial production is basically a given when you go to to a shipyard. That's easier. You can even scale from one shipyard to several, or make them collaborate. Also in South Korea, they have a rumor for being one of the highest qualities and most efficient shipyards in the world, or having those. So we can deliver really high quality products for a low price because of the efficiency. And the third point here, that that we can take only 3 years from when you order the power plant until it's plugged onto the grid. It's actually a little bit new in the energy market. Today, when we talk energy, we are planning 10 years ahead, because it takes 10 years for the short term projects. So we're planning at least 10 years ahead. So by being able to shorten that to 3 years or even shorter, it means that the energy markets don't have to plan that long ahead, which actually is a saving in itself. So that's very important. And it's also enabled by this very fast process in the maritime industry. In the energy industry, we are used to these 10 years, but in the maritime industry, nobody wants to wait too long. You want it now, and you want it to make money fast. Another thing that is fairly trivial in the maritime market is doing lump sum contracts. So as a customer, you only pay a little up front. The majority of money is paid when the power is delivered to the grid, or when the turnkey product is ready. That's a very, very big financial upside too. Then it's highly modular. So here it says that it comes in different sizes. There's a slide here on that. So a barge is basically 2 ends, a control room in one, and the other one is just an end. In the middle, you can put 1, 2, 3 units with a turbine, and in our case, 2 reactors of 100 megawatt electric each. You could also put other things. You could put desalination or fuel manufacturing, hydrogen production facilities on this barge. So it's highly modular and really agile in where you deploy it. Also, because it's a barge, you can actually move it from one grid to another. So you could actually move it in, start the grid, then move a bigger one in when the grid is big enough for that, and take the first one and put it elsewhere. So it also gives a new agility in the market, which is kind of important. So we've been going at it for a few years, and currently Seaborg is we are now more than 30 people. We have actually hired a few this week, so I'm not even sure how many we are. We have 12 PhDs, so we are quite high educated. Now we need a lot of engineers. There's a lot of engineers required here. So not too many more PhDs, but we need some. We have actually attracted people from 5 continents. It's a little bit strange that we are in Copenhagen, because before us there was one other nuclear startup in Copenhagen, which was the anti-nuclear movement. That's 30 years before us, and they actually spread globally. So the global anti-nuclear movement started in Copenhagen. So it's a little bit strange that we're also here. But Copenhagen is a really, really nice place to be. So it's a very good place to attract talent from around the world. And if we want to do a project like this, you need talent from all over the world. In fact, it's no secret that this project is high risk, and it's ridiculously hard. And when something is ridiculously hard, it doesn't mean that a lot of people think that, but it doesn't mean that it costs a lot of money or that it takes a lot of time. It means that there's risk associated with it, and that you need an extraordinary team to solve it. And an extraordinary team is not something you can hire in just a city. An extraordinary team is people from all around the world assembling into the same project. So in that regard, it's quite good to be in Copenhagen. I will also say we are hiring. Now I'm saying this. This is a recording, so when this is broadcasted, it's official. We just raised a lot of money, so we will actually be hiring 50 new people over the next half year to a year. So we'll grow quite dramatically, 8 digits in euro. So it's a big amount. We'll also build new labs and everything. So we are going into a scaling phase now, which is really exciting. So if anybody out there is listening, please apply for jobs. So that was the left side of the slide. The right side of the slide is more in the partnering and market. It's very important. We are a startup. We need to be absolutely as lazy as possible and only do one or few things. Those things has to be important. So that's what we're focused at, the core elements of the nuclear core. All the other things, how to procure nuclear fuel and how to decommission, how to build a turbine, how to build a barge, all of this is not us. This is partners around us. So we have spent a lot of energy in building some really, really good partnerships in Korea with massive players. I'm not going to name drop here, but some massive players in the nuclear industry and in the shipping industry out there we have partnered with. That is really, really strong. So we have a really, really strong partner base now. And with that, we will go out there and start this. The next phase will be getting a customer. We haven't been focused a lot of that yet, but we have just started that dialogue and it's going really good. And then the last point there is actually probably the most important point in this entire company. Everybody in the nuclear industry says that the real barrier to deployment of new types of nuclear plants is regulatory. So here I made a slide on it. Because we are maritime, we can actually pursue new regulatory pathways. I mean, we will live up to the exact same standards, the exact same international rules, the exact same safeguards and everything. So you can live up to the exact same regulations, but using another regulatory pathway. And that's very important because the nuclear regulatory pathway is really, really heavy and it's very cumbersome. And it's built very much for existing technologies. So they don't know how to handle new technologies. Ultimately, the requirement must be that it's safe and that it's reasonable to build. But currently it's very based, the nuclear regulatory system is based on compliance, not on safety. So there are other regulatory systems, such as the maritime regulatory system, that are based on safety, it being safe, not it being in compliance. Of course, you also need to be in compliance, but the core element is that it needs to be safe. And if we follow those pathways, they're actually much shorter than the nuclear pathway, and we're not dependent on regulatory systems changing or anything. So that's really good. And with that in mind, I will just say here that it's a bold claim that we are world first on this. There's a multitude of commercial reactors that have been licensed and are operating even. There's also a bunch of advanced reactors that has been licensed for research purposes, but it has never been put together. No advanced reactor in history has been licensed for commercial purposes, which is interesting. But we have actually managed as the first to clear a real regulatory process. It's only the first phase, so there are 2 more phases to go before we can build, or before we can operate. So it's a long process, but we're the first to pursue it, and we're actually also the first to clear it, which is not a small thing. And I'm sure the engineers in our team thought it was a big achievement too. It's a lot of documents that needs to be produced, and a lot of data that needs to be produced in order to get such a license. So that's really good. But importantly with this licensing process is we actually, in our estimates, cut something like 10 years off the regulatory process, and even more because it's an advanced reactor. And that means that we could potentially start serial production of these facilities already by 2023, early 2023. And we could have the first one delivering electricity to the grid in 2025. And for those that are not familiar with the energy market, if you start talking about deploying an energy project today, which is something off shelf, whatever it is, coal or gas or wind parks or whatever, something off shelf, it wouldn't be there in 2025. So we can even develop, prototype, regulate, and clear regulatory and manufacture and commission in a shorter period than you could with one of the today's off-shelf energy projects, which is almost insane. With that in mind, in the maritime regulatory system, you also get a very streamlined serial production. So you get what is called a type approval. We will get that down the road. So our product will be off-shelf with everything. All you need is a harbor where you can host the plant and a power plug to the grid. So our competitive advantages, and competitive advantage is a good word here, but what I think this slide should actually be named is laying full-on siege to the entire energy market from the seaside, because that's what we will do. These products, in our best estimates, will be much cheaper than any other energy solution on the market. And simultaneously, basically all of the competitive parameters that are in the energy market, we will also win on those. Like on the other side, we are not there yet, and there's some risk associated with the project, both in the regulatory and the tech. But if we can break through those barriers, I mean, we win on every single parameter. In construction, it's faster, shorter lead times, and it's turnkey power plants, which is, I mean, that takes a lot of risk off the customer, not the first one, but the down the road customers. Lump sum contract, which is a huge financial upside. Also, you can even take the fuel and put as part of the capex because you buy it on day one. So that gives different other economical advantages. Then there's the delivery. I mean, 200 megawatt barge is 100 meters by 30 meters. It's not very big. If you were to build a wind turbine farm the same size, it's 20 square kilometers. So it doesn't take a lot of land, and it doesn't even take any land. It's in the harbor, so it takes a harbor spot. Also, you don't need a lot of site preparation because everything is self-contained within the barge. So there's minimal site preparation, and it's easy to plug into the grid. Also, you have something on the water, so you can move it if necessary. You don't want to do that, but if you have to, you can. So that's a complete new feature in the energy market. And then on the operation side, the no requirement for refueling is really good. Also, the investment doesn't, in order to be a viable investment, you don't have to look 60 years ahead as you do with current energy projects. We can be economic on a very, very short time scale of maybe 6 to 10 years. That's long for some investors, but at least in the energy market, that's exceptionally short. And then we provide, and that's quite important, even though we are already cheaper than all these variable energy sources that are the cheapest today, at least in big parts of the world, we provide base load or load following. So it's not energy when the wind is blowing, it's energy when you need it or when you want it, and as much as you want. So that's really high value energy. And then obviously decommissioning is important, but I think that's no time for this in this talk. The last point here is actually quite important. We need to decarbonize the world, and in Denmark, I think our CO2 emission is 52 megaton a year. That's basically one of these barges operating for 24 years. We are almost there in our mitigation of CO2 with one barge. So the mitigation effect of this in CO2 is insane. With all of that said, I'll start to close this down. If we look like holistically on the market, we see a massive expand in energy production and energy need around the world. And it's vital for us as a world to expand. We also see that there are vast regions, probably something like half of the world's population, live in areas where there are no alternatives to coal and gas today, or at least no reasonable alternatives to coal and gas, which is highly problematic. Then we also look at the shipyards and see that there is not idling, but at least there's a lot of capacity in excess on existing shipyards, which could just spit these reactors out on serial assembly. So the supply chain is there, the money is there, the need is there, everything is basically there. So the big claim here is if we can break into this market with the sufficient tech development and regulatory effort, then it's virtually a low-hanging fruit to decarbonize the world with this technology. And then lastly, I will just say, when I look at the market size, if we just look at Southeast Asia as a whole and see how much coal and gas is currently planned, we would need to build 8,975 nuclear reactors of our type before 2040 to replace that, to just replace the new build, and that's in Southeast Asia. So simplifying everything, we will develop this technology in Denmark, then we will build it in South Korea, and then we will take it everywhere in the world which is near the coastline. So everyone in the world who lives within 100 kilometers off the coast will be powered by this technology. Well, in many years, it will take some time, but the market is just insane. So I think with that, I'll just conclude with the words that I think it's time for the energy industry is too slow and bulky. I think it's time for the maritime industry, which is much more lean and fast moving, to engage in this and leverage the maritime infrastructure to break into that energy market from the seaside. And I think that's the opportunity we have. So that's our vision. We want to take over the energy market from the seaside. Thank you.